Hey everyone, this is Mr. Bells. This video that I'm going to show you right now is on imaginary numbers and their use in Data A class. So not super detailed on them, but hopefully enough to make it through everything that I do in this class. Okay, here we go. So the first thing we want to talk about in terms of imaginary numbers is where the heck do they come from? Well, lots of times we'll go ahead and we'll try and solve an equation like this, say x squared plus 10 equals 0. And if I look at the video or picture of that, that would be a parabola that doesn't touch the x-axis because it's been shifted up 10. So what I'm looking for right now is, well, what if there was solutions? What if we could talk about what those things would be? Well, we know there's no real numbers here, but maybe there's something that we could do. So if I go to solve this algebraically, it would look like this: x squared is equal to negative 10, and then I'd square root, and I'd square root, and I'd get x is equal to plus or minus, because I always have to do a positive or a negative when I square root a variable. The square root of a negative 10. Well, in order for this to be true, that means there has to be something times itself that equals a negative 10. Well, up to this point, we don't have anything, because a positive times a positive equals a positive, and a negative times a negative equals a positive. But what two things multiply together equal a negative? So this is where it comes out to. So in math, some mathematicians goes, well, what if it was possible? What if it was defined? What if we could do something? And then they made it up and said, hey, we're going to use this to represent it. So they used the letter I to represent the square root of a negative number. So I is equal to the square root of a negative 1. Therefore, if I had something like, say, the square root of negative 20, I could rewrite that as I times the square root of positive 20, because, of course, the square root of 20 times the square root of negative 1 is equal to the square root of negative 20. So there's our I, and that gets to just be written like that. We usually write it in front of the radical rather than behind, so we don't think that it gets stuck under there. So that would mean if I have something like this, x squared plus 25 equals 0, that I might be able to find some answers to this. So I can get x squared equals negative 25, and square rooted, and x equals plus or minus the square root of a negative 25, which is, of course, plus or minus the square root of negative 1 times the square root of 25, because I can separate the radicals like that. Since the square root of negative 1 is I, then I get to have plus or minus I. And we know the square root of 25, that one we can actually break down as a radical, that's 5. And we usually, if it's not under the radical, we write the numbers first. So final answer, x equals plus or minus 5i. Well, if that's the case, then we should be able to do these things: add, subtract, multiply, and divide these numbers with i's in them. So now I'm going to go a little bit bigger in terms of this. There's a whole series of numbers called complex numbers, and complex numbers have a real part and an imaginary part, and it would look like this: 3 plus 4i. So there's your real part, there's your imaginary part, and together these things are called complex numbers, and that's what comes up a lot in some of the math that we're going to be doing. So if I had something like this, 3 plus 4i plus 2 minus 6i, I had a complex number plus another complex number, I should be able to know how to put these things together. Well, if I do that, I put my real parts together, so that's 5, and I put my imaginary parts together. 4i minus 6i is negative 2i. So 3 plus 4i plus 2 minus 6i is 5 minus 2i. And that's how addition works. Real parts go together, imaginary parts to go together. Now, likewise, if I had 6 minus 7i as a complex number minus negative 2 plus 5i, and I was doing subtraction of these things, we know that I can change this subtraction into addition. by simply shoving that negative through, or pushing that negative through, or if you want to call it distributing that negative through to each term. That would work out. So then I can change it to 6 minus 7i. The minus in the minus makes a plus, so that's 2. So changing this negative by shoving it through, changing it to addition, pushing the negative in, negative is positive. And then this negative to that one would be minus 5i. And then I could just do it as addition. So real parts, 8. Imaginary parts, minus 12i. So that's kind of how subtraction works, and that's really some pretty basic stuff. And then I'm going to go here, and for this data A video, if you want more detail, you can go into the pre-calc section on imaginary numbers, and it'll give you a lot more detail, but this is good enough for data A. Is multiplication, so 3 plus 4i times 2 minus 6i. So if I have something like this, and I have two terms which I can't combine because they're not like terms, and I have two more terms which I can't combine because they're not like terms, I need to do the process called FOIL, which we've done a lot. So that means first thing to first thing, 3 times 2 is 6. Outside things, that's negative 18i. Inside things is positive 8i. And then the last two things, which are the two imaginary parts, would be negative 24i squared. And it's at this point where we go to do some more like terms. So I got 6, I got a negative 18i, and a positive 18i is negative 10i. And then this is where I need to go here. Well, I squared. What the heck is I squared? Well, I could just leave it like that, but I think I know something here. So let's come back over here for this moment. If I is equal to the square root of a negative 1, then I squared must be the square root of negative 1 squared, and the square root should kill the square should kill the square root. So I squared must equal negative 1. So if I come back over to this, if I squared is equal to negative 1, that becomes negative 24 times a negative 1, which becomes positive 24. Okay, so that being negative 1, and that negative cancel each other out, so that's positive. So now I got real part, so I got 30 minus 10i. Okay, so that's kind of how multiplication works. So why don't we do this? 5 plus 3i times 6 minus 4i. Why don't you pause the video right now and try this multiplication on your own and see if you can get it correct. Go ahead and do that now. Stop it, pause it, try it, and then I'll do the process here in just a few seconds. Okay, so hopefully you did, and now we're going to play this out. So 5 times 6 is 30. Outside is negative 20i. Inside is positive 18i. And the last two things is negative 12i squared. So imaginary parts and real parts. So I got 30. I squared is negative 1, so negative 1 times negative 12 is positive 12. And then these two things go together to give me negative 2i. So 30 and 12 is 42 minus 2i. Hopefully that worked out well for you, and that all makes sense. You can try more of them in the online homework too. So I'm going to finish up a couple more things here, just so that you can see this. If I do I cubed, that's equal to negative I, because I'm just multiplying I squared by another I, which means negative 1 by another I. Negative 1 times I is, of course, negative I. And then the last one, and they repeat from here on out after that. I to the fourth just means that I'm multiplying I cubed by another I, which makes that negative I squared. And since I squared is negative 1, I to the fourth equals positive 1. Okay, so let's go ahead and do a couple of these things and see how well it processes out for you. So if I had x squared plus 36 equals 0, and I said let's solve this by factoring Then I believe maybe that you follow this, that I'd have an x plus something and an x minus something. And I need two numbers to multiply together to get 36, but the things have to be here. So if I do this as 6i and negative 6i, I believe that will work, because 6i times negative 6i is negative 36i squared, and negative 36i squared is negative and a negative, which makes positive 36, which is what we have here, and then the outside and the inside terms cancel. So when I have a positive difference of squares, then I know it factors like this. And then of course negative 6i is a 0 and 6i is a 0. Okay? I do a quick little thing. Know that, and I did this in class too, but on your calculators, if you wanted to check one of these things, we do actually have an I button. It's right down here at the decimal place. And you can see that it's in blue, so that means I'm using the second function and then that to be able to do it. So, as you know, I do calc and non-calc in this class because I want you to be proficient at both. So let's take this practice problem we did just a second ago, 5 plus 3i times 6 minus 4i, parentheses 5 plus 3i and 6 minus 4i, just like that. And I hit enter and I get 42 minus 2i, which is exactly what I got on the paper. So, last thing that I'm going to show you, because again, you can do all of the addition, subtraction, multiplication, even does division, even though we're not getting into that in a Data A class right now. Let me finish with maybe a little bit harder example problem for one of these things, and then that comes into play. So let's say that I have something like this, x squared plus 7x plus 12 equals 0. And I wanted to solve this. Well, we pretty much know on this one, factors of 12 are 1 and 12, 2 and 6, 3 and 4. So this factors into x plus 3 and x plus 4 equals 0, which means, of course, my zeros are negative 3 and negative 4, because that's the zero product property rule. Those are the two numbers that if I plugged into this equation would make that equation true. That also means that at negative 3 and at negative 4 is where this parabola has to touch. Okay? So that's basic stuff from before. Well, what happens if I had something like this? X squared plus 6x plus, let's say, 18 equals 0. Well, if I go right here onto my calculator, and I go ahead, I'm going to turn my stat plot off because I don't want that to mess up with anything. And I did x squared plus 6x plus 18, and I hit zoom 6, you can see that that parabola doesn't touch the x-axis, which means that it has to have imaginary solutions. So I'm going to go ahead and try this. Well, it's not factorable for me right now, because factors of 18 then get 6. So I'm going to have to do that completing the square process for this. So I got x squared plus 6x. I'm going to move the 18 to the other side, equals negative 18. Half my linear term is 3. 3 squared is 9, so I'm going to do plus 9 here and plus 9 here. Now, when I'm doing completing the square and I'm solving an equation, I actually do add 9 to the left side and add 9 to the right side. When I was doing the vertex, I was keeping it all on one side, so I'd add 9 here and then I'd subtract 9 over there. But that was, again, just getting it into vertex form. Okay, so this becomes x plus 3 quantity squared. Remember, that's always whatever's in your box. And if you multiplied x plus 3 times x plus 3, you'd get this. So this does simplify to that. Equals over here negative 9. Now I can square root and I can square root, and I get x plus 3 equals plus or minus, and now the square root of a negative number is an I, right? And the square root of 9 is 3, so plus or minus 3i. Now I subtract 3 from both sides, so I get x equals negative 3 plus 3i and negative 3 minus 3i. And those are my two solutions to this equation. And you're like, what? Really? That works? I don't know. Let's check it. So I've talked about this many times in the class. So let's go ahead and go here to our home screen. And I'm going to put in -3. I'm going to choose -3i first, but I could have used either one of them. -3 minus 3i, and I'm going to go ahead and store that in x. Then I'm going to go ahead and type in this original expression, because I said that that's supposed to be that solution. So x squared plus 6x plus 18. And if this is true, if that's what x equals, which we did by solving it, then this should equal 0. And you can see it does. So that's your basis on imaginary numbers and where they come into play. Remember, it's twofold. One, when we have a square root of a negative number, and how do we deal with that? And two, for the basic applications of quadratics, what happens if a parabola doesn't actually touch the x-axis? How can we still talk about the possibility for the math of that actually having a solution? And then how does it work out? So hopefully this was helpful. We'll talk to you later. Mr. Bell's out.